Hey everyone, welcome to lesson 12. I've created a new folder in our tile game directory. So I've created a new directory for lesson 12. Hopefully you do that as well. One of the things that's been requested is that we change the movement. So I was caught a little off guard by that suggestion. Um, but we have currently, you press up to go forward and left and right to turn, but it was suggested that we use the mouse for aiming, and I thought that would be a pretty good continuation on our study of vectors. So before we go further with working on the zombie, let's go ahead and do that and try and figure it out. So what I'd like to share with you is if you go to pygame.org, click on docs or just Google pygame docs, pretty much every module or package that you can install in Python will have documentation. Some are better than others. The Pygame documentation is very extensive, and it also has links to examples and things like that. So we're going to do something that I don't know how to do. So I go to the documentation and I find out. And so when it comes to handling events, every frame, any event that happens by the user, be it a press a key, a release a key, a mouse movement, a mouse button press, all of those things will fire an event and they get put into the event queue. A queue is a word for a line, okay, but put in order. And then we can process those events through our event loop in our application class by using pygame.event.get, and we just cycle through them. So I could detect an event other than a pygame quit or pygame key down. I could detect a mouse event, but there's another way to handle events. Now we handle the debugging event when pressing the H key here, but most of the keys we press are over here in the sprite class. So you can see we do pygame.key.get press. So we handle most of our keyboard input, not in the event loop, but in the update we call check keys, and we get a listing of all the keys that are pressed. Just a different way of doing it. Each has their advantages and disadvantages. But I want to do the same thing with the mouse. So instead of looking at mouse events, we're actually going to try and use the mouse module to get the position of the mouse. So pygame.mouse.get position looks like the one that we want to use. So that's the method that I'll use. So currently we have check keys, and we have our rotation set to left and right. Well, let's change that to where the left and right on the arrow keys or the A and D instead will not do that. I would like to make it to where they strafe, because I heard that suggestion as well. But let's just comment those off right now. So I'll just comment them out. Okay. And see if we can't use the mouse. So currently we're using a rotation amount, and in our update we adjust our rotation based on it. Well, I'd like to just constantly be looking at the mouse. Well, that's really kind of similar, isn't it, to how we handle our zombie. We get a vector from the player position to ourselves. So that's what I'm going to do. I'm going to use the mouse in that same way. Okay, so we'll handle the mouse look, if you will, in the update method, because right now we have our angle set to a rotation amount, mod 360. But what we're going to do is instead just make our angle, whatever it is the angle to our mouse. So let me kind of draw a picture of that. But there's one issue we're going to have to contend with, and so we'll explore that. So if this is our position here, and our mouse is over here, then what we want to do is create a vector from here to here by simply subtracting the mouse position and the player position. And then we'll simply, since angles are measured from the positive x-axis, we can create a vector in the positive x-axis and use it to kind of measure this angle by using the angle 2 method. So that's basically it. With the exception of our small little issue that we're going to have, that's pretty simple. So let's hop over to settings actually, and let's make a vector. Do we have Pygame imported? Let's go ahead and import it. Import Pygame, because I don't want to make my vector for the x-axis over and over and over again. So I'm just going to call this x-axis is pygame.math.vector2 10. It doesn't matter how big it is. So that's just a standard vector representing the x-axis, so we can use it to measure angles. So now the angle is, first we need to get a vector from our position to the mouse cursor. So I'll just call this mouse position is equal to, we saw this pygame.mouse.get position, and that returns a list or a tuple of our x and y, and the vector2 constructor has several different ways you can input. One of them is a point, a tuple. So I'll call this my mouse vector is pygame.math.vector2, and it takes in mouse position. And then I'm going to call this my look vector, which is my mouse vector minus my self.position, because if I take my position, where I want to go, minus where I am, that's how we find a vector to get there. Remember, a vector is just a set of instructions on how to move to go from point A to point B. And you find it by taking the location to point B and subtracting A. So I've got my look vect, and now I can just set my angle to be well, I actually want to take the angle from the x-axis to my look vect. That's the angle that we're rotating. So I'll say x-axis dot angle 2, and then you give it the angle 2, you give it the vector. We want to know the angle 2. So that'll tell me the amount of rotation necessary, and I shouldn't need this mod 360 anymore. And let's try running it. Okay, so as you can see, the player follows my mouse, and it works pretty well. And then what is going on here? You notice he's not looking at my mouse anymore. What's the problem, right? Well, maybe you figure it out. We're using the player's position, which is his logical positioning in the map, but my mouse is on the screen. So because we have a camera, this player's position is actually way over here. You know, if I move the player, I can't even do it actually, but I guess I can use the back button. If I move the player way over here, then he's going to always be looking left, because if my mouse is on the screen, well, that player, we've actually moved this over a whole screen worth to the right. So we need to be using the player's position as it looks on the screen. So we need to use our camera's from tile maps, we need to use the apply that returns a rect. So that's what we need to do. So we'll go back to sprites, and I've got this thing called look vect. Well, I'm going to call this location vect, and that's going to be pygame.math.vector2. And I'm going to call the camera's apply function, which is actually in our application class. And our reference to that, do you remember, is self.game. So then .camera, then .apply, and I'm going to apply it to myself. Now, this returns a rectangle, a rect. But Vector2 doesn't allow you to give it a rect because it won't know, do they mean the upper left-hand corner of the rect, the bottom right, what? Well, I want the center of my rect, and that will give me the point in the center, so I'll just say .center. Now, that will be my rect, and so I don't want to subtract our position vector. I'm going to subtract what I call my location vector. So I'll say get location on screen from camera. Just put a little comment there so we know why we did that. And hopefully we have everything working as it should. And so now I'm free to run around and move. Now I can't strafe yet because we turned off the left and right keys. But I think I might leave that as an exercise for you to do. See if you can program the character to strafe. It would be a little bit different because right now we're using a velocity, and you would have to set your velocity vector to be perpendicular to wherever you are. So if you press the left arrow, the character should strafe to the left, which is going to be, you're going to need to take their vector and rotate the vector, not just self.angle, but self.angle plus or minus 90 degrees. Okay, and that could be tricky. I haven't really thought it all out because, I don't know if that'll be consistent no matter which way you rotate it. I think it'll be pretty easy though. So I'll leave that for you to do. And instead, we're going to move on to what I was going to do, which is having the zombies run at us. So let's go to that. We're going to hop over in our sprites, and we'll go down to our zombie class and have a look at that. So we'll be doing a lot of the same stuff that we had to do with the player. We'll just be doing it for every zombie that's created. So with the player and the zombie, we'll need their position vector. We already have that. That's good. And we set our rect center to that position, so we're controlling the center of our zombie. That's good. We've already got a self.angle. Let's create a hitbox. So I'll create self.hitbox rect. It's okay to call it the exact same thing because this is the zombie's hitbox variable. Pygame.rect. And 0, 0, and let's make a setting called zombie hitbox size, and we could even not have it be a square, but I think it should probably be a square. So before we forget, let's go ahead and add that. Do we have any zombie settings section? Probably need one. Okay. How about here? Zombie settings, because we'll probably have quite a few. And I'll say zombie hitbox rect. Oh, no, hitbox size is what we said, right? And how big do we want that to be? Let me look up, what did I do last time? I did 100 and, no, I did 30. I did 30, okay. While we're here, we're going to need a zombie speed as well. So this is in pixels per second, and this is just pixels by pixels. I don't think we need to make that note though. I think it's pretty obvious. All right, so we do have it. So we have a zombie speed and a zombie hitbox size for as we need them. All right, good. And next, let's position. We created it to be at 0, 0, and that's the coordinates, and then we have its size here. Well, we want to go ahead and position it. So we'll say self.hitBoxRect.center is equal to self.rect.center. So I could have typed in the XY values that I need here, but I want to be able to position it by the center easily, so that's why I do that on a separate line. Makes that easier. And let's make the speed or the velocity vector. So here's my vector for velocity, self.vel, as we keep doing, pygame.math.vector2. And we already made zombie speed, right? So I just made it, again on the x-axis. So if I typed in zombie speed, comma zombie speed, that would actually be a diagonal vector, and would be really long. It'd actually be zombie speed times the square root of 2, almost twice as long, or almost 150% as long. So that's why I just put it on the x-axis, and then we can rotate it as we need to. We've got our angle starting at 0, which means it's already rotated correctly, and we've got our sprite group or zombie group added. All right, that all looks good. So we have our image and our rect, and we have our positioning of our rect. Okay, that looks pretty good. But now we need to be rotating our velocity vector. So let's rotate velocity vector to match the angle of rotation. So remember the velocity vector. A vector is a set of instructions for which way to go. That's exactly what our velocity does. It's going to say which direction and how fast, as it has both magnitude and direction. So we've already set the magnitude, but now we're going to set the direction. Self.velocity equals pygame.math.vector2 zombie speed. I'm thinking I don't need to create it over and over again. I can just rotate it. I can say self.velocity equals self.velocity dot rotate, and I'll just rotate it. And we need to actually rotate negative the angle. You can play around with that to see why, or else it'll go in the wrong direction. Okay, good. Next is time to move it, and this should be familiar to you now. So self.position plus equals self.velocity times self.gain.dt. Now, if we were to go further, we should really make an acceleration vector. And if we had an acceleration vector, by the way, then the change in position, which is what plus equals means change by, would actually be 1/2 times self.velocity times acceleration times self.gain.dt squared, and then plus self-velocity. So I wanted to point that out, that we're actually kind of cheating just a little bit, and we're not using acceleration. Adding an acceleration would definitely make the movement of the zombies a lot smoother. Just be more work. Okay. And after we change their position, we do need to change the location of our hitbox. And we also need to change the position of the actual positioning rectangle. And we'll just set them both to be the same place. So the hitbox rect and the zombies positioning rect are going to share the same center. Okay, cool. Hopefully that kind of works, at least for the time being. Let's take a look. Well, okay. I have my zombie is rotating in all sorts of weird ways. I'm not sure why. Let's take a look. Oh no, this doesn't work. I was thinking that this would work. This doesn't work because it's rotating more than it should. I do need to do it like this. Pygame.math. See, I tried to go off script and said, no, my notes aren't right. I don't have to create this vector every time. But apparently I do. Now I might be able to improve this if I actually create this vector like we did earlier. Create this vector in my settings. But that should fix our issue. Yeah, it does. Okay. But I'll just make a note of that. So it might be better. I can improve processing speed by making vector in settings. So instead of us creating the vector every time and rotating it, it might be faster. I'm not sure. I haven't really looked too carefully at the speed at which the vectors are created. I'm thinking they're created pretty quickly though, so it's probably not that big a deal. But when you're trying to get 60 frames per second, and if we have a lot of zombies, every little bit counts. So we should have a zombie run at us now. And there we go. Our zombie is a little slower than our player. So now there's an issue here. As you can see, the zombie can run through walls. So that's the next thing that we need to do. But I think we'll wait until next lesson to make the zombie hit the walls. Maybe I don't think it'll